let's look at these new indeterminate forms. So 1 to the infinity, infinity to the 0, and 0 to the 0. These all are not defined as anything. You might think they are, but they are not. So we have to deal with them. We have to get them into a place where we can use L'Hopital's. So L'Hopital's, we know, can only be done on these two forms. We know that when we have 0 times infinity, or infinity times 0, that we put it into a fraction so that I can use L'Hopital's. We make common denominators for this so that I can use L'Hopital's. So these, we're going to do the very similar thing. We're going to get it to a form where I can use L'Hopital. All right, so the first step is we're going to take the bold math step and let y equal the function. So here we have so we have a limit. So our first step, and I'll just kind of walk through the steps while going through this example. I'm going to let y equal x to the 1 over x. Oh, I guess I should have shown you. When I plug in infinity, I get infinity to the 0. Okay, so here goes. So let y equal to the function, then take ln of both sides. So that's the second step. Take ln of both sides. Then you're going to bring that exponent of 1 over x down. Bring that exponent 1 over x down. This might start to feel similar because we did something like this when we did logarithmic differentiation, or log diff in Math 150. But now we're going to remind ourselves we're doing a limit. So after we get to this part right here, we put the limit back in on both sides. Right? Put the limit back in on both sides. And I just rewrote this as ln of x over x so that it's L'Hopital ready. Right? I like to have a fraction. Okay. So then I'm going to pause on this side. I'm going to keep this the same, and while I go and do L'Hopital's on this side. So the derivative of ln of x is 1 over x, and the derivative of x is 1, because I do have infinity over infinity on this side. So now when I plug in infinity, I get 1 over infinity, 0 over 1, or 0. Okay, so now I know that the limit of ln of y is 0. So now I'm going to go take e of both sides. So I take e of both sides to undo the ln, because you know e and ln cancel, so I would just get y, and e to the 0 would give me 1. So the answer to the limit is 1. Let's try, this is just some other ones to do. So this is they're kind of in random order. So let's go do this one. So if I plug in 0, so you should know cotangent looks like this. So cotangent, there's infinity, right? Minus 1 over 0, and that's infinity. Okay, so I would first want to rewrite this. So this is cosine of x over sine of x. Remember, because when you have infinity minus infinity, you want to make common denominators. So carrying the limit along, so I'll have x cosine of x minus sine of x all over x sine of x. So double check, is it L'Hopital ready? If I put in 0, I get 0 times 1 minus 0, so that's 0 over 0. Yes, it is L'Hopital ready. Here we go. So I'm going to do product rule on this term. So first d second plus second d first minus the derivative of sine, which is cosine. Product rule again. First d second plus second d first. Okay. So let's look at this. Look at that. I see cosines canceling. Yes? All right. Let's clean it up a little bit. So I have negative x sine of x, cosine and cosines cancel. So on the denominator, I have this. All right, so now what happens when I evaluate it at 0? I get 0 over 0. I get to do L'Hopital again. Okay, product rule again. First d second plus second d first. Product rule on this term, first d second plus second d first plus the derivative of sine is cosine. All right, so now what happens when I plug in 0? So here I have cosine of 0 is 1, but that's times 0. Sine of 0 is 0, so I get a 0 on the numerator. This is 0, this is 1, and this is 1. 0 over 2, it's 0. So I'm done.